Stochastic in Seconds presents random variables. By definition, a random variable is a function that maps outcomes from the sample space of an experiment to the real number line. This definition might be a bit confusing, however, and it's easier to think of random variables as the outcomes of an experiment prior to collecting data. Suppose our experiment consists of rolling a die. Before the die is tossed, the number that will be rolled is a random variable, and we know that this number will be a 1, 2, 3, 4, 5, or 6, which is the sample space, or also called the support, of the random variable. Once the die is tossed and we see what the number is, then the random variable becomes a data point. Capital letters often denote random variables, and lowercase letters denote data points. Going back to our die tossing experiment, let the random variables x1, x2, x3, x4, and x5 denote the numbers rolled on the next 5 tosses of the die. After the first 2 tosses, a 3 and a 4 is then rolled. x1 and x2 are now data, and x3, x4, and x5 are still random variables. The sample space of the die rolling experiment is said to be discrete, as the possible outcomes are countable, 1, 2, 3, 4, 5, and 6. The sample space could also be continuous, however, if the outcomes cover a range of possible values which is not countable. Consider an experiment in which the amount of milk generated by a cow is to be recorded daily for the upcoming week, and it's known that the cow can produce anywhere between 0 and 100 liters in a single day. The random variable for this experiment are x1, x2, x3, x4, x5, x6, and x7, and the sample space for each day, or xi, can be any value between 0 and 100, or continuous. So we can see that random variables denote the outcomes of an experiment before collecting data, are real valued, and may be either discrete or continuous.